Hi, good day to everyone. My name is Devekant, and today I'll be presenting about promoting and communicating OSH in chemical safety for my subject OSH communication and promotion. Okay, so as you can see, this is my table of content. This is my introduction. For my introduction, I've included common chemical hazards, key safety practices, regular standards like regulatory standards, safe storage tips, emergency preparedness, and also importance. So let me start with common chemical hazards, which is flammables, corrosives, and toxins. For key safety practices, which is use of personal protective equipment, reading and understanding safety data sheets, clear and accurate chemical labeling, regulatory standards, OSHA hazard communication standards, and globally harmonized system GHS. For safe storage tips, will be separate and incompatible chemicals, ensure proper ventilations. For emergency preparedness, will be no locations of safety, showers and eye wash stations, have spill kits readily available. And lastly, for importance, will be as awareness, following safety protocols, and also continuous safety trainings. For the importance of chemical safety, which is protects human health from exposure of toxic, corrosive, and reactive substances, prevents workplace accidents such as chemical burns, fires, and explosions, ensures environment safety by minimizing spills, leaks, and improper waste disposal, supports compliance with regulatory standards, enhances workplace productivity by promoting a safe and organized laboratory environment, encourages a safety culture through proper training, signage, and regular hazard assessments, protects future research outcomes, reducing contamination and experimental errors. Common workplace chemicals such as acid and bases, flammable liquids, oxidizers, toxic substances, compressed gas, corrosives, and solvents. Routes of chemical exposure. Okay, there are four types of routes for chemical exposure, such as inhalation, skin absorption, ingestion, and injection. For inhalation, the most common route in lab in industrial settings, gas, vapors, dust, or aerosols can quickly enter bloodstream causing systemic effects. For skin absorption will be direct contact with liquids or solids may allow chemicals to penetrate skin layers, especially dangerous with solvents and lipid soluble substances. For ingestion will be usually accidental from contaminated hands, food or lab tools. Toxic effects may occur after absorption in the GI tract, and for injection will be accidental via sharp injuries. Direct entry into bloodstream can result in rapid toxicity. Hazards associated with chemicals. Beginning with health hazards, which includes toxicity, carcinogenicity, skin and respiratory irritation, can cause acute or chronic health effects depending on exposure. For physical hazards will be examples, flammable liquids, explosive materials, and reactive substances can lead to fires, explosions, or violent chemical reaction. For environmental hazards, chemical spills may pollute air, water, or soil. Persistent pollutants can harm ecosystems and aquatic life. Importance of risk assessment. Proper classifications, labeling, and handling reduces hazard potentials. Awareness and training are essential for safe lab and industrial practices. For legal regulation and standards in chemical safeties, OSHA hazard communication standards ensures that hazards of chemicals are clearly communicated to workers through labels and safety data sheets, mandates proper employee training on chemical hazards, DOSH militia usage regulations, requires employers to assess and control exposure to hazardous chemicals, mandates proper labeling and record keeping and training. And lastly, GHS, globally harmonized systems, international system for consistent classification and labeling of chemicals, introduces standardized pictograms, hazard statements, and precautionary measures. This is a safety data sheet. The overview of safety data sheet will be provides vital information on chemical hazards and helps workers handle chemicals safely. And these are the main 16 sections in a safety data sheet. How workers use safety data sheet: understand chemical hazards and safe handling practices, access SDS before handling hazardous materials, follow PPE, first aid and emergency response protocols, legal obligation to provide and assess SDS. Employers must provide SDS for hazardous chemicals. Workers must have access to SDS for safe chemical use. These are elements of a GHS labeling system, which is pictograms, signal words, hazard statements, and also precautionary statements. For pictograms, such as visual symbols to convey specific hazards, health, physical, and also environment. Each pictogram represents a specific type of hazard: flame, fire hazard, skull and crossbone toxicity, exclamation mark is irritant or skin sanitizer, corrosion causes severe damage to materials or skin. For signal word will be danger or warning. Next, hazard statements will be clear description of nature of the hazard and provides a standardized way to communicate dangers. Precautionary statement instructions on how to prevent or minimize risk, aimed at promoting safety. Chemical storage guidelines, segregation based on compatibility, labeling and containment, and also ventilation and temperature control. Store chemicals according to their compatibility groups to prevent hazardous reaction. Use clear separation based on reactivity, flammability, and toxicity. Labeling and containment. Ensure all chemicals are clearly labeled with correct identification and hazard warnings. Use appropriate containment systems. Ventilation and temperature control. Maintain proper ventilation to prevent the buildup of hazardous fumes and vapors. Store chemicals at the recommended temperature ranges to avoid degradation or hazardous reactions. PPE in chemical handling. Personal protective equipment. Essential for minimizing exposure to hazardous chemicals includes gloves, goggles, respirators, and aprons. Importance of PPE selection. Choosing the right PPE ensures effective protection against specific chemical risks. Incorrect selections can lead to exposure to harmful substances. Maintenance and replacement protocols. Regular inspection to identify wear and tear. Timely replacement of damaged PPE ensures continuous protection. Cleaning and sanitization procedures to maintain PPE functionality. Emergency response plan. So, 8 steps to spill response. Number one, assess the risk. Number two, protect. Number three, okay, for the number three will be contain of the spill. Number four will be stop the spill. Number five, reassess. Number six, clean up. Number seven, decontamination. And number eight, report and replenish. And following are the steps of each of the elements. Communication and training. Toolbox talks and safety meetings. Foster open dialogue to address immediate concerns and reinforce safety protocols. Conduct a regular safety meeting to keep the team informed about hazards, safety policies and procedures. Clear SOPs and signage. Ensure standard operating procedures are accessible and clearly outlined for all team members. Use clear visual signage to communicate critical safety information in the workplace. Continuous education and refresher programs. Offer ongoing training programs to reinforce safety practices. Provide refresher courses to ensure knowledge retention and skill updates. Sorry. This is a case study about a chemical accident which happened in Malaysia on April 1st, 2025, Putra Heights pipeline fire accident. Cause of the accident was gas pipeline leak in Petronas's pipeline network triggered an explosion and fire. impact significant damage to infrastructure, environmental concerns, and several casualties. The lessons learned are such as enhanced leak detection and monitoring. Real-time gas leak detection systems can help identify risks before they escalate, improve emergency response protocols, streamline response strategies, and better communication during industrial accidents, regular equipment inspection and maintenance, routine checks, and proactive maintenance reduce the likelihood of system failures, worker training and safety drills, proper training in handling hazardous materials and emergency evacuation procedures, best practices for chemical safety, adopt advanced safety technologies, ensure compliance with industry standards, strengthen community and environmental, foster a safety culture within the organization, emphasizing regular safety audits and drills. For the conclusion, chemical safety is a critical component of workplace health, environment protection, and operational integrity. Understanding the nature of hazardous substances, routes of exposure, and proper handling procedures, supported by legal standards, SDS documentation, and GHS labeling systems, can significantly reduce risks. Effective storage, the use of PPE, and well practiced emergency response plans are essential to preventing accidents. As demonstrated in the Putra Height pipeline fire case study, lapses in monitoring and preparedness can have severe consequences. Prioritizing continuous training, clear communication, and a proactive safety culture is the most reliable path toward preventing chemical incidents and protecting lives. These are the references I've used to complete my assignment, and thank you.